Okay, here's our second lesson on the distance formula. I have about three, four word problems that I want you to take a look at. And I want you to see how word problems can be fitted and then how we would use the distance formula from those word problems. This sheet that I have here on the screen is actually the back side of your Pythagorean theorem one where we did the television and the baseball. So you want to get that sheet back out, and so pause the video, get this sheet back out, and you want to turn it over to the back side where it says word problem practice, the distance formula. We're going to start with number 2. Now, because of the distance formula, needing some space to write your work out, don't write your work on this paper. Put your work for this on notebook paper. Okay, so you want to write your work on notebook paper for this. All right, so pause the video and get your paper out. All right, here we are back. Let's take a look. First of all, we're going to start with problem 2, and let's take a look at this together. And let's first find the question part. Where's the question mark? It's at here at the end. So let's go back here a little bit. It says, what is the radius of the cul-de-sac? Cul-de-sac. What's a cul-de-sac? Well, some of you do know what that is. For those of you that aren't sure, here's a picture of a cul-de-sac. This is actually a cul-de-sac right here. It's a cul-de-sac is where you have an area of houses and they're around a circle. So the cul-de-sac is actually this part right here, this part of the road. This is what they're talking about right here where I'm circling. This is the cul-de-sac. It's a circular dead end to a road. This is the cul-de-sac right here. That's what it's called. Okay, so this is what this word problem is talking about. Let's take a look here back at the word problem. Todd has drawn a cul-de-sac for a residential development plan. He used a compass to draw the cul-de-sac so that it would be circular, like I showed you in the picture. On his blueprint, the center of the cul-de-sac has the coordinates -1, and a point on the circle 2, 3. Okay, so most of the time I think people will maybe use 0, 0 for this, but they gave us -1, and then this other point on the circle 2, 3. What is the radius? What is the radius? So here's what they're saying, that the center of the cul-de-sac, so you've got a circle, the center of the cul-de-sac is right here, and they're saying this point right here, that's -1, -1. Right here on that point, right there, that's -1, -1. What they're then saying, there's a point on the circle that's 2, 3. So a point on the circle then would be out over here. They're talking over here, and they're saying a point here in the circle, and they're saying this point out here is 2, 3. Okay? And they say, what is the radius? Well, the radius, again, is the distance from the center of the circle, out to the edge of the circle. So I would be drawing a line from the center of the circle right out to my red dot. And I want to know how far is this distance right here. So this is the distance that I'm after. Notice how I've drawn a picture here for you. And anytime you're dealing with word problems and you're not sure what it is, you can look up a picture like I did. Say, oh, that's what it is. All I did was Google that. All I did was Google that to start with, and then put that picture inside the smartboard software so you could see it. Well, all you'd have to do is, all I did is Google the word cul-de-sac, and I got a nice picture of what it looked like. So now I've drawn a picture on the paper to help me figure out this problem. Well, at this point now I have which coordinate is 1. Well, this one is the first one they gave me, the center of the circle. So this is going to be x1. This is going to be y1. This is going to be x2. And this is going to be y2. All right, and I believe you've done enough practice with the distance formula. I won't go fill all that in for you right here in the video, but you do need to put, these are the numbers what you need to put in. This is what you put in for x1, this is y1, this is x2, and this is y2. And when you get done with the problem, you can check your answer with the answer key. I'll be happy to get it out for you and show it to you, let you take a look at it. But again, the distance they're after is from here to here. So pause the video now. Fill in that formula. Again, your distance formula is just what you did on your book assignment. If you're not sure what that formula is again and you want to copy it down, turn to page 555 in the book. Page 555 has the formula, and you can copy the formula right off that page there again to write that down on your paper so you can complete this problem. Pause the video, do this problem, and then we'll come back and take a look at number 3. Problem 3 is a landscaping problem. So I'm going to clear the ink out of there so we can have that nice and clean for us. And it looks like we have a grid, doesn't it? So we have a grid here. We have some lines drawn on a grid. Almost looks like a right triangle, doesn't it? but notice these sides are drawn diagonally, so we can't use Pythagorean theorem because I don't have actually been given actual lengths on the outside here, but I have been given two coordinates. So this is going to be a distance problem. When you've given two coordinates, you've got a grid, I can use the distance formula again. So let's find my question mark. Here's my question mark. So let's see here. I want to get a pen out. Looks like I got green right now. All right, so let's find where the question starts right here. What is the length of fencing he will need along the patio edge that borders the property line? What is the length of fencing he will need along the patio edge that borders the property line? So let's see, he plotted a triangular patio on his landscape plan for a client. Okay, so this is going to be a triangular patio. And it looks like we're going to have some landscaping along here. And here's the house over here. The property line is this dotted line where this side is. They want to know how long is it from 5'1" to 6'8". Okay, so if I'm you, the coordinate on the left is going to be the x1, y1. Coordinate on the left is going to be x1, y1. So here's x1. Here's y1. Here's x2 because it's the coordinate on the right on the graph. And here's y2. Again, I would substitute into the distance formula, and then I would just do my calculating. So I'm not going to do that now. You've done that yourself. Again, the formula is on page 555. That's where the formula is, page 555 if you need to copy it down again, or if you've forgotten it, or if you have it already in paper, great, super. Fill into that formula, and then just calculate the distance between the two dots on the grid. Notice this is talking just plain meters. So when you have your answer here, it's meters. So we've got to find out how many meters it is from 5'1" to 6'8". And we have meters going across over here. So that's nice that our units of measure are the same. We won't have to do any extra calculations there. So all I have to do, fill into that distance formula and do your calculations. Pause the video here, do problem 3, and then restart the video. Okay, you're back. If you haven't checked your answer yet, be sure that you do that at some point because we want to make sure you're doing the problem correct. All right, the next problem I want to take a look at is this one. It's marching band. The Ohio State University Marching Band performs an on-field spelling of Ohio called Script Ohio. Well, let's have a little fun with this. Let's see, where did I put that? Here's a little clip for you. I'd like for you to take a watch this clip. We'll watch about a minute of this clip, so just go ahead and watch. This is actually the band. All right. That is actually the Ohio State Marching Band, and they do perform that before every game. So let's take a look back at the word problem now. Sometimes they must adjust the usual dimensions of the word to fit it into a limited guest band performance area. The diagram below shows part of the adjusted drill chart. Each point represents one band member and the coordinates are in yards. So it's yards on the x-axis going across, yards in the y-axis going up and down. And this is, I actually had watched my high school band director do this one time. He actually placed it on a coordinate grid. And this is what they do. So let's take a look at our question. How far is the drum major from the tuba player who dots the I? And that's what you saw at the end when the drum major came walking out with the tuba player. He was dotting the I on Ohio. That's quite an honor for that tuba player. It's something each year that the band members vote upon. The drum major, there's usually a drum major also at the top of the O, so that's what you're seeing here in the diagram. So how far apart are the two? How far apart is this drum major right here, and how far apart is the tuba player? All right, you've done 2 word problems already using the distance formula. So let me clear ink off of the page. So now we have, oh, I got to use red. It's Ohio State. Got to use red. Okay, so what they're asking for is how far apart is the tuba player here to this drum major right there. Well, here are your coordinates, 2013 and 3210. Since you've been working with the distance formula and you have 2 points, I think by now you know what to do. You should be able to place these coordinates into the distance formula and do the calculation and find out how far apart they are. Notice on the worksheet there's no space down here for that, so you're going to have to do that on your sheet of paper. So go ahead now, pause the video, and do question 5 using the distance formula. Okay, lastly, let's take a look at number 6. Let's take a look here at number 6. All right, let's see here. Got to get back on that. Okay, so on number 6, it looks like I can't scroll this any further. All right, so number 6. No, yeah, I need to be able to scroll that further. Okay, I got it. So the question now says, Carol is the band member at the top left of the first O in Ohio. All right, so just to show you where they're talking about, let me pull this back a little bit on the video, just a touch, and I'll try to show you where they're talking about. Where they're talking about is on this big O over here. This is what they're talking about to start with. Carol is the band member at the top left of the first O in Ohio. She is located at 026. So we can't use this grid for Carol. How far away is Carol from the tuba player? So in other words, what they want to know is if Carol is sitting over here, how far is it from Carol all the way over here to the tuba player? Carol's over here on the left at 026, the tuba player we've been given the coordinate for. So let's go back to our worksheet. And that's way over here. So I have located at 026, and I have, where is that tuba player? He's at 2013. So I have 026, and then I have 0, and then I have 2013 right here. So I gotta use 2013 and 026. Those are the two coordinates. And if I'm you, I'm using 026 as x1 and y1, and 2013 will be x2 and y2 when I substitute those into the distance formula. So go ahead and substitute those into the distance formula. Find out how apart is somebody who's way at the big capital O from that honored tuba player at the top of the I. When you get done, check your answers. Answers are great. Turn it into me. You've done a good job. Let me know how I can help you.